Cool. So if anyone's there, can you just type in the chat to see if you can hear me well? Hopefully, yeah. Sweet. Awesome. Cool. Yeah. So I'll get started then. Cool. So yeah, welcome to this thesis presentation. Today we're going to be discussing vehicle to everything communication with a variable message sign use case. So my name is Lachlan Gilling. I'm here with Professor Paul Higgins at the Excel Technology Co offices in 17 Mile Rocks. So just to start off with a little bit about Excel itself. So founded in 1989, Excel designs, develops, manufactures and distributes intelligent transportation systems. So things like vehicle detection systems, way in motion and variable message signs. So Excel was acquired in 2015 by a company called Aldridge Electrical Industries. And that sort of really expanded Excel's ITS capabilities. And we're looking at expanding into the vehicle to everything sort of sector as well. So what is vehicle to everything? So vehicle to everything, or V2X, is basically vehicles being able to share data between each other, between infrastructure, and between all sorts of other different vehicle to everything enabled devices. So you've got vehicle to vehicle communication, vehicle to infrastructure, which is what we're going to be focusing on today, and then vehicle to pedestrian and also vehicle to network. So there's a whole different sort of bunch of applications that you can use vehicle to everything for. So different things like that for safety as well. So for safety, so vehicles being able to sort of transmit this data allows the users of the vehicles or the vehicles themselves to have better informed information, make better informed decisions about their driving. And this sort of communication is sort of leading the way for autonomous driving moving forward. And in the future, there's going to be sort of different applications with regards to infotainment as well. So as drivers sort of transition from being the drivers of vehicles to being passengers, you're going to see a lot more of things like music streaming, movie streaming, that sort of thing coming into this communication. So it's very, very exciting. And then also for road management as well. So it's important for road managers to be able to sort of see these vehicles on the road and manage their networks efficiently with this V2X technology. So these are some of the sort of safety applications that we can see. So things like do not pass warning. So for example, if you're on a highway, you want to overtake the car in front of you, but you can't see a car oncoming at you, and you go to pull out, you might get a notification saying, don't pull out, there's an oncoming traffic. And yeah, this has lots of sort of, there's a lot of safety applications that are going to sort of help save lives and make road networks a lot more efficient. So the use case that I'll be looking at today and for my thesis project is this variable message sign use case. So basically getting a message that's displayed on a variable message sign, so a VMS, like you'd see on the highway. You might see road wrecks ahead, slow down. So basically getting that sort of message and translating that into a vehicle to everything packet, and then sending that to vehicles in the surrounding sort of area, and then having those vehicles retransmit that to other vehicles sort of further away, and effectively extending the range of the message sign itself. So what we've got here in the diagram, you can sort of see the RSU, so that's the roadside unit, and then OBU is the onboard unit. So they're just some acronyms that we've got. So moving forward, this is sort of the project development summary. So basically, we had to start with a lot of research of the different sort of standards that have been in development for vehicle to everything communication. So looking at those standards, understanding where we're sort of at the moment, then looking at different literature reviews and use case studies for the BMS vehicle to everything application. And then moving on from there, actually looking at what sort of information is sent to the message signs to display the different sort of text, how we can sort of use that information to transfer that into a vehicle to everything packet, and then send that with the roadside unit, and then be able to receive that with the onboard unit, and then eventually display that on a heads-up display in the vehicle. And then at the end of this, I'll be doing actual field tests, actual trials, making sort of recommendations for how Excel can move forward and implement this technology in the future. So looking at the the standardization of vehicle to everything technology. So at the moment, there's two sort of main competing technologies. So you've got the cellular V2X, which is sort of still in development. It's probably going to be deployed in the next few years in 2021, 2022, as sort of the 5G and 4G technologies sort of improve a little bit more in Australia, especially. And then you've got the DSRC, or dedicated short range communication. So this is sort of a more, think of DSRC more of a Wi-Fi based protocol. So the 802.11 is actually a standard of IEEE that describes all sorts of different wireless communication. So 802.11 also describes your household wireless, and then the P at the end of that sort of describes the vehicle application of this wireless standard. So then breaking that down even further, you've got the two competing standards for DSRC, so the US standard and the EU standard. And up until recently, it was Australia was sort of analysing these two standards and seeing which one it would actually implement. So we've actually gone for the EU standard back in 2018. That was decided. So in the past, Excel's done a little bit of research into vehicle to everything technology. Back in 2015, Michael Drew did his thesis looking at a school zone use case for V2X technology, transmitting a message from a roadside unit to an onboard unit. He found that back in 2015, the sort of standards were very underdeveloped. He actually did his thesis project using the US standard instead of the European standard. But he was finding that you mix results with the actual line of sight communication with his the packet transmissions. So as soon as he sort of went around the corner, as you can see down here, so the RSU would be set up here. As soon as you sort of went around the corner, you lose a lot of that reliability in your packets. So yeah. So just looking at the sort of architecture of the 802.11 standard. There's a lot of different, so this is sort of like the European sort of version of it. So there's 7 different channels that it operates on about the 5.9 gigahertz radio spectrum. So looking at the control channel, that's sort of your main channel where you'll be sending sort of your main safety applications, and then moving up through the service channels is where you would find sort of vehicle-to-vehicle communication and less high priority transmissions. And this actually, the transfer speed of this is about 3 to 27 megabits per second. And you know, this standard was adopted back in 2010, so it's quite an old standard, but currently, you know, sort of standard NBN connection that you'd see at your house is about 22 megabits per second. So really, it's not awfully too slow. However, they want to sort of improve this for more advanced vehicle to everything applications. So they've sort of been working on this 802.11 PD standard, which will probably be finished and deployed in the next few years. Looking at the CAVI pilot program, so I had to sort of come up with a sort of the hardware that I was going to use for this project, the onboard units and the roadside units. So going back to the CAVI pilot program is the Cooperative and Automated Vehicle Initiative, which is sort of a group of companies that have come together to sort of test out V2X technology in Australia, using different sort of use cases and testing sort of interoperability between all sorts of different hardware devices. So it was found that in a few of the tests, this was one that was run out at Mount Cotton back in 2017, seeing sort of how different sort of systems worked with each other. And it was, so at the start of this project, I was tossing up between using a Savari device. The Savari is a California-based company, or a Coda Wireless device. And seeing by this sort of results from the CAVI pilot program, you can see that the Savari sort of didn't really perform well with interoperability with other devices. And the Coda Wireless one sort of performed a lot better. So we've gone for Coda Wireless for the project. So this is the Mark V of the Coda Wireless onboard units and roadside units. So at Excel here, we've actually got 2 of these Coda Wireless onboard units, which I'll be using to develop the system. You can actually configure the onboard units as roadside units as well. So I'll be using one as an onboard unit and then one as a roadside unit, just for testing purposes. So moving on to the actual messages, the actual message structure of the ITS. So in the facilities layer of the ETSI standard, you've got 2 sort of main messages that you'd be sending. So a CAN message and a DENIM message, so cooperative awareness message and a decentralized environment notification message. So looking at the CAN messages, so a CAN message is a message that's sent by all V2X devices, so roadside units and onboard units, and they're like a point to multi-point communication. So say your vehicle is driving down the road, it would be sending this message to the vehicles around it, sort of telling all the vehicles around it sort of where it is and how it's moving through the environment. And this sort of CAN technology, this CAN message doesn't support multi-hop forwarding, meaning that your vehicle is going to send it to another vehicle, but then that vehicle isn't going to send that CAN message to other vehicles as well. That's sort of just to keep the your vehicle sort of centralized in the local environment, not sort of hearing stuff that's happening a couple of kilometers away. So this is the sort of information that's in the CAN message. So you'd have things like the position of your vehicle, what type of technology it is. So if it's a roadside unit, a vehicle, a bus, a train, that sort of thing. And then with that basic container, you'd either send a high frequency container or a low frequency container. So your high frequency has sort of more dynamic information, like your motion state. Is your vehicle accelerating, slowing down, which way is it facing, which lane it's in, that sort of thing. And then the low frequency container would contain information like your vehicle role. So maybe you're an ambulance, maybe you've got your emergency lights on, that sort of thing. So moving on to the denim message. So the denim message is sort of what we're going to be using for the roadside unit with the message sign case. So the denim message is used to alert road users of detected events that occur in its environment. So things like the traffic environment. So if there's traffic congestion ahead, the driving environment, so slippery roads, wet roads, that sort of thing. And perhaps a road hazard, perhaps roadworks or a car accident, or perhaps a vehicle user driving the wrong way down a highway, that sort of thing. And it does support multi-hop forwarding, so you can actually forward your message onto a vehicle and then they can forward it onto other vehicles and sort of extend the range of your device. So this is sort of some of the information that you'd see in a denim. So you'd have the event position, the station type, so perhaps are you a traffic light that's sending this? Are you a variable message sign that's sending the information? The validity of that, sorry. And also you'd have things like the situation. So what event has occurred? Is it roadworks? Is it a car accident? That sort of thing. And then you've also got location as well. So the event speed, perhaps if there's a vehicle that's oncoming that you need to sort of watch out for, and that's sort of important information that would be sent in these denim messages. So looking at, so to get the message sign, to actually translate that into a denim message, I sort of had to look at what information is actually in the message sign itself. So seeing how they're actually displayed on the messages are actually displayed on the sign. So this is an example of this is the system that we'll be using, the Aldridge group controller. So the group controller sort of sits in the cabinet on the side of the road and is controlled by the Transport Management Centre to display different messages on the message sign. So there's different sort of standard that's used to sort of control this message sign, and that's all standardised by the Roads and Maritime Services in New South Wales. So basically, you'd set up some sort of plan. So say, for example, on Saturday from 6 p.m. to 10 p.m, you want to display this message. So you'd have different messages set up with different frames. Each frame can be either text or graphic frame. So perhaps you'd have night works ahead, slow down, and then a picture of the roadworks symbol. So that's all sort of standardised. And so what we can do is actually go into the management centre and actually look at how these packets are being transferred to the group controller. So basically my V2X device, my vehicle to everything device, will sit on the network and sort of listen to these packets, capture them, and then sort of transmit the V2X signal from there. At least that's what I was initially sort of planning on doing. So what I had set up here was a tap. I'd sort of sit on the Ethernet connection and sort of capture those packets coming in from the Transport Management Centre. So these are sort of some of the results that we got. So with just like the Raspberry Pi set up. So we could actually, once a text frame was set, so roadworks ahead, slow down, I can actually save that frame as just a text file. Or if I want to set like a graphics frame, you can draw sort of pictures on it, that sort of thing. You can save that as a text file as well. However, looking at this sort of information that we get from just intercepting packets to the group controller, you can sort of see that there's not a whole lot of information. So you just get the roadworks ahead. You wouldn't get any information about the actual event itself. So what I'm actually thinking of doing is instead having a separate tab in the Transport Management Centre where you'd actually start your own denim message as well as setting up the actual message on the sign. So you do those two things at the same time, just so there's more information that you can transfer in those decentralized environment notification messages. So that's sort of where we're at the moment. So converting that VMS message into a denim message and then transferring that. And then the sort of next stage after that is getting this communications between the two devices, the roadside unit and the onboard unit working, and then making up some sort of basic sort of graphical display that would display a sort of message saying, oh, you know, roadworks ahead, that sort of thing in the vehicle. And then, yeah, obviously field testing that. So this is what I've got set up downstairs on my desk at the moment. So I've got the two Coda wireless units here. So one set up as the roadside unit and one set up as the onboard unit. And at the moment, I'm able to send basic CAM and denim messages, basically just with the software development kit that they've got at the moment. And sort of like the next step will be to sort of customize those CAM messages, customize those denim messages, and send those as well. So yeah, so a connected vehicle future, it's definitely on its way. This technology is definitely going to be around the next 5 to 10 years. You'll see it a lot more. And it's going to make for more, you know, smarter vehicles, you know, lead the way for autonomous driving, and make, you know, more efficient road networks where, you know, you'll be sitting in traffic a whole lot less. And then obviously safe networks from that as well. So there'll be a whole lot less road accidents on the road. So we'll move to questions now. If anyone's got any questions, you can turn your microphone on or type in the chat if you've got any.
Lachlan, what do you anticipate as a realistic distance for reliable communication? Say a vehicle's on the motorway, travelling 100 kilometres an hour. What do you see as a reasonable distance data will go reliably?
Yeah, sure. So, so going on the actual edit itself, so the 802.11p, the sort of physical layer, it's sort of rated for, you know, less than 1,000 meters, so less than a kilometer distance away. However, you know, this is affected also by, you know, if there's trees in the way, if there's buildings in the way, you know, it can severely sort of limit that range. However, if you use the multi-hop routing instead, so if you're sending a message to a vehicle, that vehicle can then send that sort of back down the line to vehicles behind it and all around it, sort of thing. So you can effectively get quite a lot of range out of it. However, you know, using the message sign case, you probably would really require more than, you know, a kilometre sort of range anyway. So yeah, looking into that, it probably yeah, we'll be looking into a few more different sort of use cases where we can use the message sign as well. Yeah, cool. So, yeah.
If thinking about the situation where looking at Bruce Highway, vehicles are travelling towards Brisbane and the message is being broadcast over a wider area, don't necessarily want it to go to the vehicles that are travelling north. Any thoughts about how you'll manage that?
Yeah, sure. So with the let's get to the denim messages. Yeah, so with these denim messages, you can actually transmit them to specific lanes and specific headings. So depending on your roadside unit will be sitting there listening to a whole bunch of different CAM messages, which are transmitted from all sorts of vehicles, and they'd have which lane they're in, which way they're heading, what their motion state is. And then you can actually, with your roadside unit, you can actually send the denim messages to specific lanes, to specific areas. So you might not want your denim message to go outside of a kilometre range. You might only want to sort of notify people maybe with like 20 metres or 100 metres, that sort of thing. And you can actually set that up in the denim message when you transfer that. So yeah, so that'd be one of the nicer ways.
Yeah, good. Thank you. Well done.
Cool. So if there aren't any sort of further questions, no one else has got any questions in the chat. Yeah, I'd just like to thank everyone for coming along and listening to the presentation. Yeah, I'd like to thank you, Paul, as well for being here and sort of supplying all procuring all the materials and equipment that I need. And yeah, thanks to Excel Technology for sort of facilitating the development of this project. Cool. So thank you for coming along.